Hi everyone. Welcome to the channel. Today, we are talking about connecting op-amps. We will link an op-amp to a second amplifier stage. This is a common task in electronics. But there is a hidden pitfall. It is called the loading effect. We need to understand this. It ensures our circuits work as intended. Let's dive in. What is loading? Imagine pouring water from a big tank into a small cup. The cup is the load. If the cup is too big, the tank might not fill it properly. In electronics, loading happens when a circuit draws too much current. It happens from the previous stage. This affects the signal. It can change its voltage or shape. This is not good for our design. Op-amps are great. They have low output impedance. This means they can deliver current well. But they are not perfect. They still have some internal resistance. This is the output impedance, Z_out. The second stage amplifier has an input impedance, Z_in. When you connect them, these impedances interact. Think of it as a voltage divider. The op-amp's output voltage divides. It divides between its own Z_out and the second stage's Z_in. If Z_in is too low, most of the signal voltage drops across Z_out. This reduces the signal reaching your second stage. This is the core of the loading problem. This voltage division leads to problems. First, you get reduced gain. The signal going into the second stage is smaller. So the overall amplification is less than expected. Second, you might get distortion. If the op-amp is forced to supply too much current, it might not operate linearly. The output waveform can become clipped or distorted. Your audio might sound bad. Your data might be corrupted. We want a clean signal. So, how do we fix this? The key is impedance matching. But not in the traditional sense for power. Here, we want minimal loading. First, ensure your second stage amplifier has a very high input impedance. Much higher than the op-amp's output impedance. A good rule of thumb is Z_in should be at least 10 times Z_out. Even better, make it 100 times. This way, most of the voltage drops across Z_in. Second, op-amps naturally have low output impedance. This is a good starting point. But always check the datasheet. Third, sometimes, a simple voltage follower or buffer stage is needed. You place this buffer between the op-amp and the second stage. A buffer has very high input impedance. It has very low output impedance. It passes the voltage without changing it. It acts like an impedance transformer. It isolates the op-amp from the load. This is a very effective solution. It prevents loading. It ensures maximum signal transfer. Understanding loading effects is crucial for good circuit design. It helps you get the performance you expect. Thank you for watching this video. I hope this explanation was clear and helpful. If you found this useful, please hit the like button. Share it with your friends. And don't forget to subscribe to the channel for more electronics content. Your support helps us create more videos like this. See you next time.